So we will wait another 2 to 3 minutes. Join the student. Otherwise, we will start our lecture. Okay. Now we'll fill the attendance till now. Today's attendance. Today's first lecture of 29. I'm sorry, Jay, the So on Saturday, Thursday we have the practical class in afternoon. We will continue that, and today we will continue the lecture. Already we are far behind. Or today, inshallah, we will finish our unit number 5 already. We have finished lots of material in that. So in morning we have seen about the self-compacting concrete, as well as we have seen the uh, fiber reinforcement concrete. Before that, we have seen lightweight concrete in yesterday class, and also we have seen no fines concrete and foam concrete. Also, high density or concrete we have seen yesterday. And today we have seen the compacting, self-compacting concrete, that is also called as self-consolidated concrete, and the fiber reinforced concrete. And also I have shown you different types of fibers available in the market or can be used. It may be natural fiber, it may be artificial fiber, but most of the fibers they are using as a additional material in the concrete to enhance the properties of concrete, mostly the tensile strength of concrete, and also it arrests the yani, cracking of your concrete. Okay, so We will see today the GPC. That is now we will see the geopolymer concrete. Also, what is geopolymer concrete? We will see today, and we can understand it very. I will just because I'm forgetting every time. This one you can see geopolymer. So geo means earth, polymer, you know, it is a chain of the polymers. It may be SiO2 or Na2O or C2O, etc. SiO3. They make a chain, and that chain of polymers is called as uh, geopolymer concrete. So many such concretes are available in the market, uh, but this is the special case, the geopolymer concrete. So geo means earth and polymers mean concrete. So there are different uh, papers and lots of research work uh, is already done on the geopolymer concrete. So you can see the geopolymers are the structure, their reactions and properties you can see here. So generally this is a concrete which is made with concrete made with without cement. In ordinary concrete, we can remember that in ordinary concrete, the main ingredients are the cement, water, aggregate, and admixture. But in case of geopolymer concrete, in place of cement, we are using the cementitious materials that is having the cementitious properties such as fly ash, rice ash, or silica fume, etc. Also the slag. So geopolymer concrete is produced uh, with a use of alkali, and the process of hardening of geopolymer concrete is due to the polymerization reaction. Uh, in case of ordinary concrete, the process is uh, uh, sorry, is hydration. So the calcium silicate hydrates are formed, and mostly they are responsible for the strength gain, and that is the CSH gel. You are saying that CSH, calcium silicate hydrate, and after the reaction of hydration, this will, and the hydration reaction is the also exothermic reaction because of heat is involved in that case, and that's why the process of hydration is there. That's why the hydrates are formed, that's calcium silicate hydrates, and that reaction is called as hydration reaction. But in case of geopolymer concrete, in case of the geopolymer concrete, the reaction is not uh, hydration. The reaction is polymerization. So here, one French scientist, Mr. Davidovitz, is first introduced the geopolymer concrete in 90s. Geopolymer concrete, polymer concrete, polymer impregnated concrete is different, and geopolymer concrete is different. Huh? Don't mix it. Okay, so we will see the geopolymer.org is the website of this Mr. Davidovitz, and many such information are available on that website. So you can see this website, that is www.geopolymer.org. Uh, uh, www.geopolymer.org is the website for the children. So you can many contents are there, and history of geopolymer concrete is also is there, and many uh, things. The introduction of geopolymer and previous is used by the geopolymer concrete by the Romans and by the this sorry pyramids of Misr. You can say they are used at earlier ages making of concrete, and that is not any but this is evolved and very much and, this concrete is very fastly taken into this because this geopolymer concrete, it is evaded the use of cement. It is evaded the use of cement totally. So there are many geopolymer books are published nowadays, and that's why this is included in your syllabus also. So this is written by the Dr. Joseph Davidovich, a practical and scientific approach by sustainable development, fifth edition. This book, Geopolymer Concrete, by Joseph Davidovich. So in 1979 or 1978, he is yani, evolved, evolved. Who is this? Who is this person? So this geopolymer concrete are evolved. So you can say the many books are written by the Dr. Joseph Davidovich on geopolymer concrete. So the basic difference between the this ordinary concrete we are using normal weight concrete and geopolymer concrete is the process of strength gain. That is, in geopolymer concrete is the reaction is geopolymerization, whereas in sorry in in ordinary concrete the reaction is hydrogen.
सर इसमें
Uh,
रिएक्टिंग प्रोडक्ट कौन सा रहेगा?
just I am coming to that. Just wait. Yes, we will coming to that. Okay. Geopolymer concrete. I also worked on this geopolymer concrete in 2014 and 13, and also worked on this, and I have got the strength up to 100 MPa. Okay, 100 MPa is not less; it is a high strength concrete. So in IS code, it is given that the strength more than 55 MPa is under the high strength concrete. Okay, so 100 MPa I got when I have done the practical, made this concrete in 2012 and 2013 during my master degree. So, so here the activated material for the fly ash is nothing but uh, this uh, sodium hydroxide and sodium silicate. Yeah. So you can see the content of the ingredients of durable concrete is, you can see the this polarized fly ash, or it may be in blended of the fly ash and the uh, GGBFS, and then activated solutions are there. It may be NOH solution, it may be the sodium silicate solution and water, Water is required only to prepare these solutions, in this solution. And then fine and coarse aggregate, as usual, we are using in the normal concrete. So you will get the product same as normal concrete, you can see. But the difference is that here is the reaction between the activated solution, that are the alkalis, and the fly ash. And the activated solution, they will activate the fly ash and GGBFS, or it may be the rice haskell, it may be the silica food. They activate that, and that matrix that will make a paste. Here there is no use of cement. Either you can use cement, or you can totally avoid the use of cement. That's why somehow this is called as maybe green concrete. But because he because the process of here also there is process of heat involved. That's why they are not calling it green concrete. But the use of byproduct material, because the fly ash is from the thermal power station, and the ground granulated blast furnace slag is from the iron industry. So these are the byproduct material. So we can use that byproduct material, either dumping on the ground, yani we are uh, uh, avoiding to dumping of the fly ash and GGBS on our agricultural land, and by using in the construction material, it is very useful. For this, geopolymer concrete is the very best option for that. So why not we are using the uh, ordinary Portland cement? You know that, and many times I told you, the production of 1 ton of cement is uh, yani, production of 1 ton of cement is releasing of 1 ton of carbon dioxide into the atmosphere. 1 ton production of carbon dioxide for every ton of cement when you produce. So it is very harmful and greenhouse gas effect, and it is very harmful for our environment, and that's why the global warming and the ozone layer depletion cases are due to the increase of carbon dioxide into the atmosphere. There are many reasons other than this also, but this is also, if we can reduce the use of cement, then we are saving our planet of Earth from contamination. Uh, so is there a way to use a OPC without environmental impact? Yes, there is a way, and that is a way is showing the geopolymer. So reduces the demand of OPC, which leads to carbon dioxide. Utilize waste material from industries such as fly ash, silicone, GPS. All this already I have discussed with you. Conserve the acres of land would be used for the dumping of the disposal of the fly ash and the GGBS. So also contamination of water bodies uh, through the disposal of fly ash and etc. That can be reduced by the use of geopolymer concrete. The constituents I told you, that is the coarse aggregate, fine aggregate, admixture, alkaline activator are used in place of cement. So alkaline activation is a process of mixing powdery aluminum silicate with alkaline activator, and it produces a paste which sets and hardens within a short duration, but it requires heat for uh, fast reaction, because the polymerization is reaction impulsion. The alkaline activator commonly used are the sodium or potassium hydroxide. They are used in the combination with the sodium silicate. Also, it is also called as water glass, sodium silicate, or potassium silicate solution, or combination of these two can be used for making the concrete. These are the alkaline solutions. It may be produced from the hydroxide, sodium hydroxide, potassium hydroxide, or from the. Now we'll see the fly ash we are using for the geopolymer concrete and their properties, because higher content of silica is there in your your fly ash and ground granulated blast furnace slag. Okay, so this is the chemical composition of fly ash in this slide. And fly is used in concrete increase the life cycle expectancy and increasing durability. And fly's particle are spherical in shape, though, so that improves the compaction or consolidation of the concrete. And GGBS also there is constituents. You can say that silicon is also greater than uh, cement, which may be used. Selective film also, and another. Uh, the process is the Si, that is silicon aluminum atom present in the concrete. They will uh, they will react with the sodium hydroxide and sodium silicate solution, and they will produce uh, the SiO2 AlO2 reaction. तो जैसा कि हमने यहाँ पर देखा, ये हमारी पुरानी स्लाइड you can see here the chain of the reaction of the, you can see this Si K, you can see this of the bond between the silaxo bond, it is called O, this O, here against O, this I, silicon, aluminum, then the covalent bonds are formed, and this form and very strong bonds formation is there. That is the chemistry of geopolymerization. So that can be, you can see, okay, another option is not there. Okay, sure. So mechanism of the geopolymerization is the dissolution of Si and Al atoms takes place. जैसे ही हम we use the activator solution, and the OH ions are formed. Then precursor ion condense to form a monomers, and monomers are very uh, bound, and then polycondensation of monomers to form a polymeric structure. And this framework form is called as polyseriates, and these polyseriates are nothing but hyded. Then seriates stand for silicon oxo aluminum building unit chains and rings formed across the link through the SiOLO bridge is formed, and that is nothing but the process of your polymerization. So many types of geopolymer you can produce by the slag-based geopolymer, uh, rock-based geopolymer, but there should be present of silica in large quantity. Fly-based geopolymer are mostly used uh, in nowadays. So fly ash is very easily available into the market because of large thermal power plants are there in India. In nearby Malegaon, you can say there is Bhusawal or thermal power plant is there. Nasik having a India Bull site, a core thermal power plant of 250 megawatt, already declared. There also our government thermal power plant is there, and abundant of fly ash are available for using for manufacturing of the concrete or construction product. It may be block, it may be concrete, it may be the you can say used in concrete, or most of most of the uh, uh, fly ashes are used in cement production also. Also, you can prepare a geopolymer cement by this. So this solution, geopolymers, the source is SiAl, that is silicon and aluminum for geopolymers. Can any mineral remain metaline also, fly ash or VGBS we are discussing. Then the water blast, there is sodium silicate and sodium hydroxide. These are the activator solutions, and the process of uh, that is nothing but the geopolymerization reaction, and that is produces the hydrates of by reaction. and that process they make a bond of the SiO bond, and that is nothing but the condensation of the and the hydrolyzed aluminates and silicates are polycondensate, and then hardening is taken place. So you can say here how the mixing is done. You can see the activator solution plus fly ash plus fine and coarse aggregate. You can see in the mixer here, first here you can mix sand and aggregate together, then add fly ash, then you do the dry mix, and then add the activator solution, and your geopolymer concrete is ready. You can see this in this mold, the concrete is placed, and this is nothing but geopolymer concrete. It is very self-consolidated and very cohesive mix if you produce a geopolymer concrete. And you can see the compare the strength of concrete. You can see the OPC is the yellow line. This yellow line shows the OPC, and this is shows the geopolymer concrete by the red line. The strength is very high, up to 60 MPa. You can get for very low temperature. So you can see the chemical resistance, and then durability properties also. It is checked that is chemical resistance of the geopolymer concrete is also very good. So you can see the yellow line is sorry, blue line is the class F fly ash based geopolymer concrete. This one, and below that class C. Uh, uh, this one is the for class C fly ash geopolymer concrete, and this yellow line is showing at the ordinary concrete based on the OPC cement. The pH of this is zero point 0.6 acidic, and you can see the properties. The compressive strength is reducing as it is immersed in the sulfuric acid uh, for 1 week, 2 week, 3 week, and 6 week, and 8 week. So geopolymer concrete you can see with the class F fly ash gives a very best result, and there is no such impact or reduction of the concrete. So we can say that these geopolymer concretes are very durable concrete and can be used for our regular or ordinary concrete. Okay, so this is very important, very important, and uh, in produce precautions to be taken because these alkali activators are very harmful for the human skin. You have to prepare, and it is very safe. So all this will affect the geopolymer concrete will reduce the use of cement, and simultaneously it will help us reducing the pollution into the environment due to cement production, and that's why this material can be called as sustainable material because we are using the fly ash that is byproduct material. So 480 million tons of fly ash produced in 2001, and nowadays the fly ash production, if you search on the internet, it is too high. If you search in internet, the fly ash production of fly ash production, let us uh, you can see uh, fly ash production in India. So you can see the data of 93.26 million tons in the 2018-19, and uh, in first of 2019-20, uh, India generate around 217 million tons of fly ash, and utilization of fly ash is up to 78%, and 40 million tons of fly ash are to be dumped for a year. So this is what is the impact of the fly ash on our climate, and many such you can see nowadays the fly ash. Uh, we are making the blocks and many things by using the fly ash. So this is what about the uh, your geopolymer concrete. Okay. So generally it doesn't require moist cooling. Geopolymer concrete it doesn't require moist cooling. Okay. Compressed स्टेबिलिटी जो हम लोग ने बात किया it is more than modulus of elasticity and Poisson ratio is also you can see comparatively uh, good and gravity is also good resistance against the sulfuric acid as you have seen there is no such resistance loss application for the humans. In Roorkee, I have visited IIT Roorkee. There is CBRI. So you can search CBRI. That is Central Bureau for Building Research. That institute is they have already one road they have prepared with the geopolymer concrete. Water tanks with the geopolymer concrete. The thickness is very small. You can see the precast products. Also the boat ram made by the geopolymer concrete. And but see the finishing of the geopolymer products are very good. Beams, girders, arch, core sockets are very impressive and produce. The advantage of GPC high compressive strength, high tensile strength, low creep, low drying sink resistant to heat and cold, chemical resistant. We just have seen the sulfuric acid is highly durable and it is also fireproof to uh, the sun extent. Difficult to create or require special handling because the sodium hydroxide and sodium uh, silicate they both are the harmful for human. Sodium hydroxide will be very harmful for and that is the pre-mixing is required and the process is very sensitive and there is lack of uniformity in the product. That is the disadvantage of this product. But nowadays, if you care or take care, you can do. Tubular concrete is a promising construction material due to its low carbon dioxide emission, high earning strength, low creep and shrinkage, also acid resistant. It is also the fire resistant, makes better usage than OBC. It is widespread application in the precast industry due to its high production in short duration, less breakage during the transportation, also enhance the research along the acceptance required to make it grade advanced. Here are some uh, there are some references. Also, you can see I have also published a paper on geopolymer concrete. So my paper also you can refer, you can study. So I have already published a paper on geopolymer concrete. So available. So this is papers I have published in the journal. That is on the geopolymer concrete. That is effect of fly ash content on the properties of geopolymer concrete. This one is my guide. We have published in 2015. Also, some papers published latest also uh, in 2020. Also, have published one paper. Papers, publications, research, so many papers also published by my students are also. and also you can use the this one the latest one 2020 I published this paper based on effect of different curing system on strength characteristic of geopolymer concrete. This paper also published. You can also study and publish on international journal. That is very helpful for your future. So this is one about the geopolymer concrete. So it is a newer development and many such papers are there. You can study and you will get how the production is done of the geopolymer concretes. Okay. So to start, we will here. This is all about the geopolymer concrete. There are also many some papers are there which are very good. It can be you can see the fiber reinforced geopolymer concrete. Morning we have seen the fiber reinforcement concrete. So you can use the fibers also in the geopolymer concrete and then see geopol concrete the reaction you can see. So the term geopolymer coined with the David, the scientist first uh, will observe the geopolymer concrete and introduce to the world how to make design geopolymer concrete. There are something many people have done. Also, Patin Kavital has done a very good job on mixed design of the geopolymer concrete. Uh, then you can see the comparison results and design for the fiber reinforcement. And in this conclusion, they have from their research work that the mixed production of geopolymer concrete depends upon the fineness of fly ash, grading of fine aggregate, concentration of alkaline liquid, ratio between alkaline liquid, ratio between the fly ash and the alkaline liquid also. The tensile strength of parameter improved by the incorporation of polypropylene and glass fibers. With the polyethylene and glass fiber, the tensile strength is improved. Also, the compressive strength, split tensile strength, and flexural strength was found to be more for the addition of 0.03% glass fiber on volume of concrete. Some technical studies showed a result of increase in the compressive strength by the incorporation of polypropylene fiber, while some others showed a decrease in compressive strength due to the hydrophobic characteristic of the polypropylene fiber. So the many such papers are also studies or researchers have written their work on the geopolymer concrete. So you can go for that and you can see on internet you search many such uh, concrete production you can find out. So geopolymer concrete just you can type on many uh, presentation you can observe in the slide. This already you have seen. Another one you can uh, click on many such sites here geopolymer based on the from geopolymer concrete is available. Okay, so that will help you for that is also many such research I have done, I have also done, and that you can see on the internet also is available. So this is what all about the geopolymer concrete, and then we will go for the another type of concrete. That is concrete uh, ferrocement concrete. So already today we will finish what is the ferrocement, ferrocement concrete. It is very yani, interesting to see you that the ferrocement is nothing but ferro means the iron, है ना? Ferrous means the iron. Okay. So many such ferrocement concretes are you can see. So fiber reinforced concrete already we have gone through that. Engineer cementitious composite or some special concrete you can also you can see ultra high performance concrete is another type of concrete, and then slurry infiltrated fibrous concrete and slurry infiltrated matte concrete, silicone. So then many slurry infiltrated concrete are used nowadays for the concrete purpose. Now you can see the ferrocement concrete. Ferrocement is also known as ferrocrete, invented by the Jean Lewis. So ferrocement is invented by Jean Lewis, Louis Lambert of France in 1848. So you can see the this is the France scientist who in 1848 discovered the uh, ferrocement. Uh, it is also called as ferrocement is also called as ferrocrete. So it consists of steel bars placed in tension zone, whereas ferrocement is a thin RCC made rich cement mortar concrete and in a ratio of 1:3. Based on matrix reinforcement with the closely spaced layers of relatively small diameter wire mesh, welded mesh, or chicken mesh are used. The diameter of wires ranges from 4.2 to 9.5 mm, very small, are spaced 300 mm apart. The mesh may be metallic or synthetic. In Malegaon also, this you can see the ferrocement uh, tanks are produced in Malegaon. Generally, septic tanks you can see are produced ferrocement water tanks. If you see the images, so many such images you can find out. So ferrocement tanks are considered wire mesh and there is plasting is going on. So these are known as the ferrocement. The ferrous material that's iron, and then the plasting is with the mortar, of which mortar having this after the finishing you see the finishing very thin thickness is there, and this you can see the thickness is very thin, and this you can say these are nothing but the ferrocement tanks, and this product. So you can see the reinforcement. You can see the reinforcement various. Only the wire mesh are there, and some vertical bars and small quantities are used. This is called as ferrocement or ferrocrete. Also, they see the groundwater tank resting on the ground. You can see that ferrous refining is done. Okay. So, such a concrete, which very fine, thin mesh, and with when we do the plastering with uh, then you can produce such a tank with a very thin sort of ferrous tank you can see, and that is called as ferrocement. It is called as ferrocement. You can see the tanks. Huh? The different tanks you can see. So this is made by the ferrocement, yani with the chicken mesh or the closely spaced small diameter mesh, and then also, you can see the ornamental jalis we are putting at our staircase. They are nothing but the ferrocement. वो भी उसके अंदर आप देखेंगे उसको ब्रेक करके तो you can get into the that the chicken mesh or wire mesh are there. And small bars are also provided, and the mesh may be metallic or synthetic. It may be non-metallic. The mortar matrix should be of excellent flow characteristics and high durability. The proselytic mineral molecules such as fly ash 50% cement replacement can be recommended, and use of superplasticizer will not only permit the use of water binder ratio of 0.4 to 0.45. The water binder ratio then is 0.42, Why here water binder? Why not use the term water to cement ratio? Because water binder ratio means fly ash. If we in very fine fly ash if we make, then fly ash is also reactive. So that's why the water binder ratio is told here rather than water to cement ratio. A mortar compressive strength is around 40 to 50 MPa is recommended for the ferrocement. During the 1940s, the Pier Luigi Nervi, an Italian engineer, an architect, and the contractor, had used ferrocement for the construction of aircraft hangar, boats, and buildings. तो उन्होंने एयरक्राफ्ट हैंगर भी बनाए, बोट्स भी बनाए इससे. And it has been noted that though the Navy used a large number of meshes in its structure, in many present day applications, only two layers of mesh reinforcement are used. है ना, पहले क्या है उनको मालूम नहीं था तो उन्होंने ज़्यादा मेश यूज किया, लेकिन आप जहाँ जहाँ पर आप टेंशन आपका होता है वहीं पर हम लोग mesh यूज करते हैं क्योंकि ये स्टील इज स्ट्रॉन्ग इन टेंशन. Application of ferrocement include the boards, barges, वाटर टैंक. वाटर टैंक का पता है मैंने. पाइप्स भी आप देखते हो जो ड्रेनेज पाइप हम लोग यूज़ करते हैं वो भी फेरोसीमेंट से बनता है. बायोगैस डाइजेस्टर, सेप्टिक टैंक हमारे मालेगांव में ज़्यादातर यूज होता है. टॉयलेट ब्लॉक्स है, मोनोलिथिक है, प्री फैब्रिकेटेड हाउसिंग है. ऑल दिस थिंग्स आर नथिंग बट फेरोसीमेंट. Okay, there are many such polymer concretes are there, and we will see in the next class. And you can search the special types of concrete, and you can special uh, concretes, and you get many such concrete you don't know. Okay, that is also available, and you can uh, search, and you can find out special types of concrete. Many videos are there. Videos are also there, and images and literatures are also available. You can search and you can verify. So any question you can ask with me, or otherwise we will do. We will do today, and we, in morning tomorrow morning 9 a.m. our lecture is there. So we will start the unit number 6 tomorrow inshallah. Thank you for your. If you have any question, you can ask it.